Hey guys, how's it going? Welcome to day 5, secant secant exterior angles. So yesterday we looked at secant secant interior. Now we're looking at secant secant exterior. So once again, we have those lines that touch the circle twice, but this time they're not intersecting inside of the circle, they're intersecting outside of the circle. We want to figure out how that angle relates to the bends, just like yesterday, but now we're working with exterior angles. So let's take a look at an example here. We're set up to do an example, and then we're going to do the proof, and then we're going to look at some more examples. Okay, so here we see this is a secant line, or part of a secant line. I guess it doesn't extend forever. But we see that this touches the circle twice. This one touches the circle twice as well. But they intersect outside of the circle. So how does this angle X relate to this bend of 100 and this bend of 20? Well, again, in order to figure this out, we go back to stuff that we know from before. And we're going to go back to our good friend inscribed angle. So I'm going to connect 2 points here. Now, once we learn the rule, we don't have to draw these in anymore, but this is kind of like how we discover the rule. So I'm just going to connect 2 points on here. I'm going to connect this point and this point. Okay. By drawing that red line in there, what I do is I create a triangle first off. So I have a triangle right here. Remember, this 20 degrees is for the bend. That 20 degrees is not an angle in this triangle, right? So I got a triangle. I've got an inscribed angle here. And I've got an inscribed angle here. And I'm going to use that triangle exterior angle theorem again. So the first thing I'm going to do here is figure out the measures of those inscribed angles. Okay? The first one I'm looking for is this angle right here. Well, that's an inscribed angle. It's hitting an arc of 100 degrees. And the rule is angle equals bend over 2 for inscribed angles. So I know this angle right here has to be 50 degrees. Next, I'm going to focus on this inscribed angle. This inscribed angle intercepts an arc with a bend of 20 degrees. So I take half of that and I get 10 degrees for this angle right here. And then what I want you to see here is in this triangle, I have X here, I have 10 here, and I have 50 here. And the rule is non-adjacent plus non-adjacent equals exterior. So I know that X plus 10 has to equal 50. So what does that give me for X? Well, that gives me X has a measure of 40. Okay, but the question is, how can I get that 40 without drawing in this line and finding these? Okay, how does 40 relate to those original bends of 20 and 100? Right, when the problem was first written, I had 120. Right, I had 100 here and 20 here. Well, if we take a look at these, right, let's think about what we were doing. We were taking half of this one, 50, minus half of this one, 10. Right, and what we can see here is we can do this bend, 100, minus 20 gives us 80, and 80 divided by 2 gives us that answer of 40. So here's the rule for secant secant exterior. The rule is angle equals now, if you notice, we have to do big bend, right? This is our big bend, the one that's farther away. This one right here is our little bend. And when we do subtraction, it matters the order that we subtract, right? If I did 20 minus 100, that would give me negative 80. Negative 80 negative 80 divided by 2 is negative 40. I can't have an angle with negative degrees here. So it has to be, the order has to be big bend minus little bend over 2. So I have to subtract big minus little on top. Otherwise, I'm going to get a negative number, right? If you get an answer and it's negative, you know you set your equation up wrong. Okay, so here is our formula that we're going to be using for this. Let's just prove it to make sure it works in all cases. And again, connecting these two, I get this angle to be z over 2. I get this angle to be y over 2, right? Because that's how inscribed angles work. This inscribed angle is half of y. This inscribed angle is half of z. And what I know then is x plus y over 2 has to equal z over 2. When I subtract this over, I get x equals z over 2 minus y over 2. They already have a common denominator, so I can condense this to call it x equals z minus y over 2. Again, let's think about what this represented. X was the angle. Z was the big bend. And y was the little bend. Okay. So let's take a look at some examples, because we could have an unknown as an angle, an unknown as a big bend, or an unknown as a little bend. And they all work just a little bit different on how we solve them. Same equation, just depends on where x goes. So let's do 3 examples. Here's example 1. So here's example 1. And again, I'm following the formula, angle equals, because I see this intersection is outside of the circle, right? It's not inside of the circle. If it was, I'd do it like yesterday's video and do bend plus bend over 2. But this is exterior, so I got to do angle equals big bend minus little bend over 2. So when I see this setup, I say, okay, what's my angle? Well, my angle is listed as x, so I'm putting in x for my angle. And that has to equal big bend. Big bend is 105 minus little bend, which is 35, divided by 2. Now I notice x is already by itself, so all I have to do is simplify the right side of my equation. 105 minus 35 would be 70 over 2, and 70 divided by 2 is 35. So x ended up equaling 35. Try another example. Okay. So I take a look here, and again, I'm following the formula angle equals big bend minus little bend over 2. So I'm going to start with angle equals. This time I know my angle is 30 degrees, so I'm going to start off solving this with 30 equals. And I've got to do big bend. Which one's my big bend? It's the one that's farther away. This is my big bend. So I've got x minus my little bend, which is 50 over 2. So I'm using the same formula, just my variable or my unknown shows up somewhere different than it did before. So now I just have to figure out, how do I solve this problem? How do I solve for x? Well, I'm going to start by multiplying both sides by 2. So I'm going to get 60 equals x minus 50. And then to get x by itself, I have to add 50 to both sides. And I get 110 equals x. And again, I can check this by saying, okay, 110 minus 50, that's 60. 60 divided by 2 is 30. Okay, let's look at one more example. And we'll be done. Okay, so the first one, the angle was unknown. The second one, the big bend, was unknown. In the third example, our little bend is unknown. Okay, but we always start with the same formula, and it's just important to make sure things go where they're supposed to go. So I need to start off with angle equals. I know my angle is 20 degrees, right? This is the only angle here. This is a bend, and this is a bend. So I start angle equals, so I'm going to say 20 equals big bend, which I know, the big bend is 110, minus little bend, x over 2. Again, I got to solve for x. So the first thing I have to do here is multiply by 2. Do it to both sides, and I get 40 equals 110 minus x. Now, what I see a lot of students do when they get here is they subtract 110, and they're like, oh no, I got a negative number. I must have did something wrong. I must have done something wrong. Well, no, because if you subtract 110 here, you will get a negative number, but that negative number equals negative x. Okay, so when you subtract 110, right, most people probably go to their calculator. 110 minus 40 is negative 70. But again, that equals negative x. We can just divide by negative 1 and say x equals 70. Okay. The other thing you can do, it's actually my preferred way of doing it. What I like to do is just add x to both sides. And I'll say x plus 40 equals 110 minus 40. When you do it this way, since we have a positive x, my answer comes up as a positive 7. Either way you do that, you just have to be careful with your signs there. Now plugging it back in here, right, if this bend is 70, 110 minus 70 is 40. 40 divided by 2 is 20, so we know it works. All right, that's it for today. Bye.